You will be able to you should be able to download the exam 4. I said it that you could download the exam 4. Today we're going to have a short class. Okay, so you'll be able to use the time if you want to work on the exam. As always, the exam will be due back, by Wednesday at 11:59. So you got all day today and all day tomorrow to work the exam. Okay. What I want to do today is I want to talk about a problem that the type of problem you're going to have on the final. Okay. And so I want you to try to do this problem here. I guarantee you the students that are not here will not get this right. But it's a simple problem. So I want you to try to do this problem, then I'll do the solution. You will have a problem. The department thinks that this is a very basic problem that that everybody that's taking differential equations should know how to solve. So see if you can solve it, and then I'll solve it. Some of the people that just signed on were you should be trying to do this problem here.
Son bestial de la vie s'interroge.
Okay, I'm going to give you another minute. All right, let me go ahead and solve this problem. I'm actually going to show you the solution. Let's see. Am I going to be able to do this? Let's see. Try to do this a little bit differently. Okay, so in part A, right, it says we have initial value model. Okay, so first of all, we have a substance that we have 8 grams of radioactive decay substance present, and we're told what the half-life is. All right, it's 62 hours. And the rate of decay is proportional to the amount present. So based on this information here, right, we want to find what the initial value problem is that models this, okay? And they're telling us to let A be the amount present, T be the time, and K be the constant proportionality. So this is the differential equation, right? This is pretty straightforward, that the rate is proportional, right, to the amount. So that's our differential equation. Remember, when we have an initial value problem, we have to have the differential equation, and we have to have the initial condition, right? So let's see. So this is our differential equation, right? And this is the initial condition. So make sure you include those two things when you're requested to give an initial value problem, right? The differential equation and the initial condition. Pretty simple, right? I mean, it doesn't get, you don't get a more complicated differential equation than this. And then the next thing is to solve the differential equation you found in part A. Now, make this K positive, okay? Because when it comes, when we get to part C, we're going to see that the K is going to be negative. It's going to give us, is going to be actually a negative number, all right? Because we're dealing with a decay, right? We're not dealing with a growth. We're dealing with a decay. All right. So then you're going to solve the differential equation, right? I assume that everybody in this class knows how to solve a differential equation like this, right? It's a separate, we could solve this by separation of variables, right? You bring the A down here and the K over here. And this is the, this is just a natural log of A plus KT plus a constant, right? And then remember now that I can write this as A is equal to EKT plus C, right? When you take the exponential of both sides. And then I can write this C as a different C, okay? And then I apply the initial condition. So now we get that the amount is equal to 8 times e to the minus kt. So that should make sense. At time t equals 0, this is 1, and so A is equal to 8 grams at time t equals 0. Now they want to know how much substance is left after 24 hours. Well, we don't know what K is, right? We don't know what K is. Now, we actually did a number of problems like this. Also, you had some WebAssign problems. I did problem in class where we were dealing with Newton's law of heating and cooling, right? And so you have to find out what's going on. You have, in order to get what K is, right? In order to get what K is, I have to put in the 24 hours. I got to put in the 24 hours. And the fact that, excuse me, I don't put it in, yeah. Well, they want to know how much substance is left at 24 hours. So I'm told that the half-life is 64 hours. I'm told that the half-life is 62 hours, right? The half-life is 62 hours. So if I initially start out with 8, right? I initially start out with 8. Then the half-life at 62 hours, I'm going to have 4, right? The half-life is half. So at 62 hours, I have 4, and then I could solve this for K, right? So we solve this for K, and we get K is equal to minus 0.01117, okay, whatever. You can also just write K like this, right? I can leave it like this and put it to the equation, all right? And then now once I solve for K, now how much substance is left at 24 hours? Well, it's just given by, now I just put 24 hours in here, and that's my answer. Is there any questions on this problem? You want me to write it out? I think it's pretty straightforward, right? You write the differential equation, make sure you include the initial condition, right? You solve the differential equation, right? And then you're using the fact that that the half-life is 62 hours, right? The half-life is 62 hours. So this is going to be 4 in this case. Half of 8 is 4. And then I can solve this for K. And then once I solve for K, then I can put in the 24 hours and solve it for A. All right, so this is a very basic, and you will have a problem just like this. So I'm really helping you out. You can have a problem just like this with different numbers. So I want everybody to get this right. At least everybody that's here, I'm sure everybody that's here is going to get this right. And I guarantee that the people that are not here, half of them will get it wrong. Okay, So, like I said, we'll have a short class today. You know, like, as I said previously, if we were doing things in the classroom, we wouldn't have any class today. But I did just want to review at least one problem that's going to be on the final exam. I'm going to review another problem tomorrow. And tomorrow we'll talk a little bit about the final. There'll be no class on Thursday. Okay, so Thursday, and I'll put out an announcement on Blackboard too, and email it to everybody. But on Thursday, you'll be able to download the exam at 8:30 in the morning. Okay, after 8:30 in the morning, you'll be able to download the exam on Thursday, and it'll be due back on Friday. Okay, so that's kind of it for today. Before you leave, make sure you can download the exam 4. And good luck on exam 4. And I'll see you again tomorrow. And then Thursday, you know, we won't have any class on Thursday. Okay, so if anybody has questions, I'll stay on, but you can start working on exam 4. So that's it for today.
Thank you.
Okay, have a good day. Good luck on the exam.
Thank you, Professor. You have a great day.
You too.